Let's see the next topic, allocation methods. Okay, so there we will discuss about three major allocation methods for disk space. Okay, so first one is contiguous allocation, second one linked allocation, third one indexed allocation. Okay, so contiguous allocation requires each file to copy a set of contiguous blocks on the disk. Okay, so we need to assign set of contiguous blocks on the list. That means entire file is present at one place. Okay, at one place, that means a sequence of blocks will be there. So that particular sequence of blocks we need to store that particular data. So here, with this sequence ordering, if there is a process p, accessing a accessing a block, that is zero, accessing one after zero requires no head movement because they are beside one after other. Okay, so if you access a block 0, then there will be no head movement to access block 1 because it is immediate. The next block will be 1, that this block will also belongs to the same file. Look at here, there are different files are there, count. Okay, so there is a starting block will be 0 and it has two contiguous blocks. Okay, the length defines how many contiguous blocks it is occupying. Okay, so the directory entry for each file indicates the address of the starting block and the length of area allocated to this particular file. Length of area allocated to this particular file. See, if you can see, these are allocated blocks. These are allocated blocks, and white ones are free blocks. White ones are free blocks. Okay, so accessing a file that has been allocated contiguous is very easy because there will be no random head movements will be there. The head movements will be, the blocks will be on sequence order. So we can access 0, then access 1, then access 2, access 3. Okay, so it will be easy to access the file which is stored contiguously. Okay, so then both sequential and this contiguous allocation support both sequential access and direct access. Sequential and direct access. Okay, but the problem with contiguous allocation is we need to find a space for a new file. We need to find a space for a new file. See, whenever the file is created, the size of the file is less than 1k. Size of the file will be less than 1k because an empty file will be created. Initially, the size of the file equal to 0. Okay, but if you keep on adding the data, the size of the file will be increased. The size of the file will be increased. Okay, so let's see, that means we are storing the data dynamically. When a file is used by a process, if any data is stored onto the file, the size of the file will be increased. Okay, so the contiguous allocation problem occurs in a dynamic storage allocation that involves how to satisfy request size n from the list of freeholds. So we need to remember the point here. If a file is present in the in the disk and the entire size, even though the storage is comes from dynamic allocation, that means at the time of running of a process, the file size is increased. Okay, so we need to store these increased file sizes also in the contiguous blocks, but we don't know how much will be the size of a particular file. Okay, so similarly, if as files are allocated and deleted, the free disk space is broken into little pieces. So the problem comes here is, one, the we have given contiguous blocks. Let's see here. We have given contiguous blocks. Now we have given 0 and 1 to count 5. 0 and 1 to count 5. And there are 4 blocks, 2, 3, 4, 5, which are free. The free space manager will have this information. The counting after 0, 1, 2, 3, 4, 5 are free. But as the file size increases, it will allocate block number 2, block number 3, block number 4, and block number 5. Now, if the file size is more than these two blocks, that means 2, 3, 4, 5 are given to count, still the file size is increased. Then block number 6 and 7 are not free. They are allocated to a file called f. Okay, so this will become a problem when dynamic storage allocation will be done. This will become a problem because see, we have several free blocks. We have several free blocks, but the contiguous blocks are 4. Contiguous blocks are 4. This will lead to the problem of external fragmentation. External fragmentation. See, if the file needs one more block after allocating these 4 blocks, it only needs one more block. Because of contiguous allocation property, we cannot allocate to 6 7, and we cannot allocate 8 9 10 11 also. Okay, so in order to allocate this one, what we should do, we need to delete this particular data and put it onto 8 9 10 11 12 13. That means we need to take these 6 blocks to store it into 6 blocks. But next time again this particular problem comes, the file size will be increased, again there will be no free block next to 13. So this will become harder if we keep on doing contiguous allocation. So this finding a space for a new file and the size will be increased at the random, that is at the runtime, will be a problem because there may be a several number of holes are there, but not all the holes are at the same place. Okay, so the general solution that this particular external fragmentation is doing compaction. Compaction means moving all the free space at one place and used at one place. Used at one place. But compaction is not suitable with the large size hard disk. That means if a hard disk size is 1 TB or 2 TB or 500 GB and etc., 500 to 250 GB or etc., it will take a lot of time. It will take a lot of time for this particular compaction process. So it is not suitable with the hard disk of size with several GBs and TBs. Okay, we don't go for compaction. Okay, next problem with this particular contiguous allocation, determining how much space is needed for a file. Okay, that we already discussed. So how much space will be needed in the runtime, we don't know. We don't know. So contiguous allocation gives the problem of external fragmentation. Okay, and allocation is also not that easy at the runtime. So we'll go to next concept called linked allocation. Okay, so linked allocation has implemented to avoid the problem, overcome the problem of contiguous allocation. Okay, so here in the linked allocation, the file is a linked list of blocks. These blocks scattered throughout the list. That means there are this particular there will be some free blocks. There will be some free blocks. Okay, all the free blocks will be maintained by free space manager. Okay, and the allocated blocks, file allocated blocks will be pointed by one block after other block using a linked list. Using a linked list, we use the concept of pointers here. Okay, the directory contains, that means this particular directory contains a pointer to the first block and the last blocks of the file. First and last blocks of the file, and each block will have a pointer and the data block and the pointer block. That means this is a linked list. Okay, so this will be your block of data and this will be the pointer to next block, pointer to next block. Okay, so here let's see the file called g. The start value equal to 9, so here it is 9. Okay, the next block, this is ninth block. Okay, the next block will have the number 25, so this ninth block is pointing to block number, sorry, ninth block is pointing to block number 70. Okay, this seventh block is pointing to block number 1. So 9 point, the pointer will pointing to block number 17, 17 will pointing to 1, 1 will point to 2, 2 will point to 26, and 25, sorry, 2 will pointing to 25, 2 will be pointing to 25. So it will, when it reaches to 25, when it reaches to 25, that will be the last block address. And here in this particular linked allocation, allocation of a new block is very easy. Allocation of new block is very easy when the file is size is increased at the runtime. There will be a list of blocks, list of free blocks. They are scattered throughout this particular disk. We can point to any block, we can point to any block. Okay, right. So after 25 we can assign it to 22, then we can give it to 31, then we can go to 30, because the creating the new files and deleting the new files will be done, the space will be deleted, the block, these blocks will be free. So these blocks can be given the assigning the new blocks, assigning of new blocks, that means adding the new data while the file size is. Now, for each block, there will be 512 bytes. Assume that there is a 512 bytes. Assume that there is each block contains 512 bytes. Okay. In these 512 bytes, assume that there are 4 bytes for pointer and 508 bytes for your data. Okay, right. So the pointer in linked allocation, the pointers will take some amount of data. Will take some amount of data. A file of 5 blocks might start with block number 9, continue to block number 16, 1, 10, and finally ends at 25. That will be this particular file G. Okay. So each directory entry has a pointer to the first disk block of the file. First disk block of the file. A pointer is initialized to null if it is an empty file. If it is an empty file, okay, and the size of the particular file equal to set to 0. Okay, so reading requires to read the blocks from one block to other block. Okay, advantages will be there will be no external fragmentation because we don't require contiguous memory allocation. There will be no limitation on the size. How many number of blocks is required, we can allocate those number of blocks by putting a pointer onto next block and next block to next block. And this linked list allocation will avoid the compaction. There is no need for compaction. Okay, no need for concept of compaction. It will avoid compaction. Okay, but the problems or disadvantages of this particular linked allocation is it is ineffective for direct access. That means if we want to go to 10th block, if we want to go to 10th block, we need to start and move to 10th block from the starting pointer to end point. 10th block, okay, ith block. We need to look at each and every pointer. We need to look at each and every pointer until we see that particular block, until we go to that particular block. Okay, and there will be a space. It will take some space for pointers. It will take some space for pointers. That is, as we have seen, a pointer will take 8 bytes of data, 4 bytes of data in a 512 bytes of block. Okay, that means 508 of data and 4 bytes of pointer. If you take this one, then 0.78% of the disk space is being used for pointers rather than information. Okay, so out of 100%, 0.78% of data will be used for disk space. Okay, and there is a problem with reliability. That means suppose that if any one of the pointer are lost or damaged, that means let us take 1 2 3 4 5 blocks. Okay, so each block is pointed by other block. Suppose that this block, okay, is this pointer is lost or corrupted, then the entire data that is connected, blocks numbers that is connected to this particular block, okay, pointer will be lost. Okay, so we don't if we made any mistake in this particular thing, we lose entire data, so that the file may be corrupt, the file doesn't contain the data, full data. Okay, so let's see indexed allocation. In the indexed allocation, we have an index block. Okay, this particular index block consisting of list of block numbers that is allocated to this particular file. Okay, the directory entry consisting of a index block, directory entry consisting of a index block number contains the address of the index block. To find the ith block, we use the pointer in the ith block entry. Okay, so when the file is created, all pointers in the index block are set to null. A new file will be created, that is an empty file, it is null. Once you write the data onto that particular file, each and every block is allocated. We write the block numbers into the file. We write the block numbers into the file. But the advantages of this particular index allocation is it supports direct access and it avoids the problem of external fragmentation. Any free block in the disk can be, we can store the data onto the, we can give that particular block to the corresponding file. And the disadvantage is that with the small files, okay, with the small files that consisting of one or two blocks, okay, uh, we need to allocate the entire index block. We need to allocate the entire index block. So that will waste the space for complete index block, as well as there is a pointer overhead.